Hello everybody.
Hi guys.
I'm Carl Pennings, RC for the Benelux, CEE and some other countries. And today I will present this topic together with Jeremy.
Hi, I'm Jeremy, also RSC for the region of France and international.
I'd like to welcome you all to this year's Dialogue 2021. And we are happy to see you all online. Last year we talked about the support topics and also the version 13 solution design. This year we want to dive a little bit deeper in the topic. We checked our ticket system and we picked a ticket that is coming up quite frequently. And it's also relevant in this time where a lot of people work from the home office. The topic will be Ice, stun and turn. As you can see, we have it here on our cap. What's the secret behind ICE? ICE stands for Interactive Connectivity Establishment. ICE is a protocol that enables to find a working media path, RTP media path, via NAT boundaries. With ICE we check which media RTP passes are available and which will deliver a working scenario for all of our phones and devices. To identify the possible IP candidates for our media endpoints, for example, the telephones to our PBX, we use additional protocols. One of these protocols is STUN. STUN stands for Session Traversal Utilities for NAT. This protocol enables a client in a LAN to determine its own public IP address and port. This allows the calling client in the LAN to tell the called client outside the LAN which IP address and port number can be used to enable a direct communication with each other. We call it a peer-to-peer connection. The other protocol that we will use is TURN. TURN stands for Traversal Using Relays Around NAT. This acts as a server in the network, in the internet or in the LAN, that implements the TURN protocol. It enables two clients to exchange data without a direct connection. That's why it's called the relay server. This is necessary if there is no way to establish a direct peer-to-peer connection. I talked sometimes about NAT. What does NAT mean? NAT stands for Network Address Translation. And we have different types of NAT. At first we have the full cone NAT. With this, VoIP devices work in general fine. An open NAT mapping accepts packets from all external IP ports. Then we have also restricted cone NAT. This is a little bit more restrictive, as the name already says. It opens a NAT mapping, accepts packets only from public IP addresses where previously packets are sent to. Then we have the port restricted cone NAT. It's like the restricted cone NAT, but here for the previous sent packets the port must also match. So IP address and port must match. And then at the end we have symmetric NAT. With symmetric NAT, to every external destination, a different NAT mapping will be used. Because this is the most restrictive one, this will not work for the STUN protocol. So now we're going to explain the STUN protocol a little bit more in detail. We just explained what we need for ICE, STUN and TURN. Now we will have a more closer look how STUN exactly works. We have the next step, the next setup with two endpoints in different LAN environments. which cannot reach each other directly. Each LAN has of course its own access to the internet with a NAT router, where the internal private IP address will be exchanged by a public external address. On the left side, the endpoint with the IP address 172.16.76.203 and the NAT address 88.197.51.34. On the right side, the endpoint with the IP address in the 192 network and the public IP address, the NAT address, that starts with 46. In the middle, there's a STAN server with the IP address 194.78.234.98. On the endpoints, the STAN server with this IP address are configured. What is the process now? And how will the devices and when will the devices start the ICE mechanism? Well, it starts with the start of a call and when answering a call. After the connect in the signaling, so it will start if you answer an incoming call, and the reason is that you can call that your call can ring on several different endpoints devices, like the DEC device, a smartphone or a desk phone. And you can answer at a device of your choice. It doesn't make sense to start the NAT detection on all of the devices that are ringing. So it will be started only at the answering device. The endpoints now collect the local candidates. The local candidates of the interface that are available. At first, its own local IP address, or in some cases multiple IP addresses, which will be shown as host address. Because they are reachable via NAT, but don't know their NAT address on the outside, a STAN request will be generated to the STAN server. It literally asks which public IP address and port are being used. The result will also be added to the local candidates as a surflex address. This is the external IP address and port from the NAT/firewall. Via the signaling of the endpoints, all local candidates will be exchanged with the remote endpoint and show as candidates remote. Now the endpoints will start the ICE checks to verify which IP address, which IP path the RTP audio transport can use. This means the endpoint tries to reach all candidates remote. The endpoint on the left side tries to reach the host address 192.168.2.101 from the endpoint of the right side. This will obviously fail because these private IP addresses will not be routed over the internet. You can recognize this at the red line. The endpoint on the left side also tries to reach the candidate's remote, the surflex address on the right side. This will be a successful result. You can see it in the green line. This process will also be executed by the endpoint on the right side. The first path that will give a positive result will be used for the RTP path in your connection. We earlier talked about the different NAT technologies, and depending on which NAT technology has been used, it is possible that no successful connection will be established with the STAN mechanism. Which option do we have in that case? Well, in that case we will need the turn mechanism. How this works with the turn protocol, are we going to explain in the next slides. Also here we have our endpoint on the left and right side, both behind NAT. Instead of the STAN server in the middle, we now have a turn server. On both endpoints is the turn server configured with the IP address of the turn server and the credentials for this turn server, like the turn user and the turn password. Here it is important that we use on all devices the same turn server. When using different turn servers, this can only work when both turn servers have a direct connection to each other, preferably they are in the same network or on the public internet. Also here the process is that endpoints collect their local candidates via the passes that are available. On the left side, this will be the 172.16.76.203 as a host address. By the request at the turn server, the endpoints will receive the IP address and the reserved port from the turn server. In this case, it is the 194.78.234.98 and the port 16400. This will be stored in the candidate's local as a relay address. Effectively, this will be seen as an extra network interface via which the endpoint device is reachable. Via the signaling now, the endpoints will exchange their local candidates and will be shown as candidates remote. In the next step, after the connect, the endpoints will do the ICE checks and identifies which IP passes can be used for the RTP audio pass in the connection. The endpoint tries to reach all candidate remotes. The endpoint on the left side tries to reach the host address 192.168.2.101 of the endpoint on the right side. This obviously will fail again because of the private IP addresses. Also, the endpoint on the left side tries to reach the candidate's remote, the relay address 194.78.234.98 and port number 16500 of the turn server. This will be successful. This complete process will also be done by the endpoint on the right side as well. The first successful communication path will be used for the RTP audio pass. If a turn server is configured, this connection path will be verified by the ICE checks as well, as we have seen before. As explained, the turn server will be used as media relay point. About media relay, this can also be configured on the PBX, but we do strongly advise not to use this because of the CPU load on the PBX. The turn server will be configured during the install on the PBX by default. This is fine in small scenarios, but in large scenarios we advise to use a separate device for the turn service. In the next slide we're going to look to some diagnostics that will be done by Jeremy.
Thanks, Carl. So now that we all have learned our lessons about stun and turn, let's talk a little bit about how we can debug and also have debug tools from our software. If you are using the stun and turn services directly from our system, so regardless of the model, on the IP4 NAT you can activate the service. As Carl already said, you can run the system as a stun and turn server. And of course, if you enable it, you need to configure the stun change address in order to perform NAT detection on the client side. So all of you, and I think it was a lot of people have configured this without knowing what is this, a NAT detection on the client side. So regardless of the endpoint, an IP phone, a PBX, a DECT antenna, under IP4 general stun, you configure the client side, so the stun server and the turn server, which will be used for the communication. And if you don't know which kind of NAT you will go through, you can activate the NAT detection. So this activated only if you need to know which kind of NAT technology you are facing off. If you don't need this, if you already know it, just don't activate it. That's it. And if you want to do a proper NAT detection on the server side, as I said again, you need to activate stun change address. Of course, this is working if you're using the innovaphone system as a stun server. So if you're using another stun server from your carrier, for example, then you don't need to activate this on the server side. So that's why we also recommend to use and configure your own stun server. So you can give this as a public service or just regular service for your customers. Then you can do a proper debug if you have any stun or turn issues. We will talk about the turn debug later on. Also, on the new softphone app, if you go to the settings, so it's called the burger menu, a hamburger menu, you can, if you scroll down, you have a network, a menu or section, I would say, and you have a little bit small arrow triangle. If you click on it, you will see on the client side which kind of host, server reflective and relay addresses are used by the softphone. So basically those settings are coming from the PBX. So if you configure the PBX on the client side, the stun and turn server, the softphone will get its information from there. So that's why it's important to configure the stun and turn server in the PBX. Regarding the ICE tracing, you can activate under tracing the H323 ICE flag. You don't need other trace flag if you want to analyze every ICE traffic, I would say. And you can use the trace continuous. So it's easier to read the trace continuous. You just click on the button and then you have all traces. If you already have a buffer in the trace continuous, just go to another menu, click again to trace continuous, and then you will have the page completely refreshed with the brand new traces. And then you can start a call in order to trace the ICE messages. Of course, if you need it for the SIP stack, you can activate it manually with a special command which are documented here. Now, the most funniest part. Let's check step by step a nice trace. So what means all of those messages, and in order that you have a better understanding of what's going on when you have when you are doing a call, and if the call is working or not, or if you have no audio or one-way audio. So first, I will call this section the collection of information. So as a client, I have different server configured, the stun and the turn. And then I need to reach the first stun server. So that's why we have an initialize message stun. So you just get basically your own IP address, so the IP address which will be used. And then we will find also the host address. So basically it's your local IP address. So if I'm in a LAN, like here the 192.168.2.103, this is my own IP address, so the IP address of the IP phone or the soft one. And then this turn server address, so we will find also the turn server address. So be careful if you are using a DNS, this can be also an issue. If you don't have DNS resolution, then you can have also issue to resolve the DNS name with the IP addresses. And then we are starting to gather and collect every information. So basically, I know all of my IPs, so my public one, my local one, and my relay one, I would say. And we are summing up everything into, I would say, a summary, which is called candidate local. So local means this is my own IP address, so I'm known with them. And we have different IPs, so for, of course, the RTP and the RTCP, so you will see different IPs and different use port. And then we are sending this, as Carl already said, my local candidate to the other endpoint. So when I'm doing a call, I'm starting a call to another endpoint, and I'm sending my candidate. So the other endpoint will receive those candidates as a remote. So you will see they will exchange the local and the remote information. So then, why we are doing this? It's just because we need to know each endpoint. We need to know where I should send my RTP packet in order to have a voice and a successful audio call. And after this, when every endpoint knows each other, so each information of endpoints, we are doing RTP check. Means, okay, I'm checking the path, the routes, which can I use to send my RTP packet, means the voice. And I will do some check because not every route or path are working, depending of the NAT technology, depending of the system configuration. And you will see a lot of lines like this, starting with minus. So it's not a hyphen, it's a minus, means not good, so frozen, which is not a good path to send the RTP packet. And the good one will be identified with a plus. So the line which is starting with a plus is a good and working one. So on the presentation you can identify it where it is in the bold, written in the bold character. So by this way we know, okay, I can send my RTP packet. So me, the 10.10.11.210, need to send my RTP packet to my RTP to the 145, 253, 157.61. So basically this is a relay address, or server reflective address. And these checks, they are automatically done, so you cannot control them. So that's why it's important also to configure everything. Even if you say, okay, I'm in a LAN, I don't need a turn, I don't need a stun, you don't know. It's an automatic system, so better to give everything in order to have a proper RTP checks. And at the end, you will see a message which is conclusion success. So it means, okay, we found the path, so now we can start to communicate. So regarding the flow of the ICE mechanism, that's it. And then we will have also some debug information. So as you can see, here we will explain when you see some conclusion fail, for instance. So it means that no media paths are found. This can happen. So if, for instance, no turn server is configured and you need the turn server, so this will fail. And you will recognize it because after 10 till 20 seconds, you will have a timeout and the audio will be gone. So the call will be hang up automatically. Of course, if you are doing a renegotiation or if you terminate the call before you establish a communication, you will see the connection aborted. So it means that something happens and you wanted to finish it earlier, so we abort the requests. Also, if both endpoints are using, for example, different stun server and one of them is slower than the other one, so they are not synced, they cannot start the ICE and stun request at the same time. So some of the endpoint can be faster than the other. Then you will see also this request, this stun error, which means that we need to restart again this stun request. So don't worry if you see those kind of errors. You just need to understand that they are not sync, and one of them is faster than the other one. And when the ICE is successful, you will see those turn messages that can be ignored, turn refreshed, the channel binding, and so on and so on. So these are just mainstream messages of the turn server. And I think, just give me a sec. Yeah, this is the last slide. You have a Slido, some question regarding, okay, now I have a communication and I have an issue. So how can you recognize a failing ICE mechanism during a call? So we have to answer it. So I hope that you will answer it correctly. I think it's now pretty clear. And during the quiz, I will explain you also on the turn server. So if you are running the turn server in an innovaphone system, you can see all sessions, so allocated sessions. So in order to communicate, so when the turn server is relaying the different RTP packets, you will see a lot of lines, a lot of allocated channels, and some information can be relevant and important to understand for you. So the first IP address and port, this is the source IP of the local media endpoint. The 0 is the amount of packets which are going through this connection. Then the 40 seconds, this is the connection duration. And then the numbers of 4000, 4001 and 2, they are meant to identify the different IPs information. So from the remote media endpoint, from the host, from the server reflective, from the relay address, etc., etc. Here you can see, okay, the local client is using this IP address, and I can compare it with what is present in the turn server debug page. So that's why I think personally it's important to provide those service by yourself in order that you can do a proper debug and have a full understanding of what's going on for each call. It's not like, okay, the audio is not working and I don't understand why. So I will ask to innovaphone support why it's not working. You can already try to understand by yourself. And of course, every information that you gathered, you can send it to the innovaphone support in order that we can help you properly. So I think that's it. I hope this was pretty clear for you guys.
Maybe there are some questions coming in.
Maybe yes, maybe no.
We'll see.
Yeah.
How was the found candidates communicated to? Sorry, so I will repeat. Okay.
Sorry, we have one-way audio now.
The ice is not going well this time. Okay.
Sorry, second try. So we have one question.
Yeah.
How are the found candidates communicated to the other party we invite?
So I think it's during the signaling. So when you will start a call, we will establish a H323 signaling. And from the softphone, it will be a WebSocket connection. And in this signaling, we will send also the information to the other endpoint. So my information, I send it over the signaling.
Yeah.
This
and the phone that answers the call will also send the information back to the calling party.
Yeah.
So in the signaling, these ICE candidates are exchanged to each other. And at the moment that the answering phone picks up, then the ICE mechanism will be transferred, or the ICE checks will be done and checked which part will be a successful one.
And this is not only innovaphone's specific stuff. On SIP, if a good example, if you check a SIP trace when you start a call, an external call over your SIP provider, you can see in the SDP, the M line, if you don't deactivate this, you can see all ICE information which are sent to the provider. And this can be deactivated, no ICE, because sometimes the provider don't like it or it's too much. So it works with H323 and also with SIP. So this is a standard signaling information, I would say.
Correct. Maybe some more questions?
No, no more question. Just a feedback that it was a very nice presentation.
Okay,
thank you very well. Maybe some questions come up later. Remind that we have a session in this afternoon, and you can join there, and we can discuss some other topics as well.
During the afternoon, and also during the afternoon, we will have a chance also to talk about our training. So we are open to answer to every question, but we have prepared also some stuff about our training concept. So please join during this afternoon that we can talk about it. Many thanks.
Okay, thank you all, and see you again.
Yep. So we are still here, and we are still staying here. We will now talk about something which is really exciting, I would say. Our new concept or technical webinar. So we want to provide, I don't know yet if it will be on a regular base or not, but we want to start a technical webinar. And the first one which will talk about the security. So security with innovaphone systems. So we want to show you, explain you, and debate with you about security topics, because within today, it's really important to have a security and good understanding of security aspect. And we will talk about the conceptual possibilities, the monitoring, the configuration. So think that you need to be careful about it. And of course, it will involve the reverse proxy, the session border controller, and also the PBX best practice of the security configuration. Like here, don't put the PBX on the public internet in order to not expose it to some attacks. Also, we will talk about the configuration, as I already said, and of course some configuration which can be interesting. So the threshold or the disk space and the configure mail on the app platform. So if you don't know already, with the V13 or 2, we have new features from the app platform, so from the manager, in order that you can get notified if the disk is full or will be soon full, in order to don't have any failing or issues with the system when the disk is full. And also different logins, like for instance the failed logins of the brute force attacks from the myApps client in the logs. So we will talk about all of these aspects. Yeah. And the most important thing for you, it's a date. So
yeah, for the English participants, we have a date on 24th of November. So check your calendar and reserve that date to join our webinar. For the German participants, we have a date on the 25th of November. So we hope to see you all then back again.
Yeah. So now we are finally done with the technical presentation. I see that we have some other question, or?
Yes, just a remark concerning the polls. The most of the people give the right answers.
Okay, nice. Of both, or?
Of both, yes.
Okay.
So I didn't mislead them with my cap.
Yeah. Perhaps you can give the right answer for the people.
So this means that we expect to have less support ticket about ICE issues. So if you understand
the right answer was obviously C for correct. And when everybody answered that, fine. We're happy. Then they listened good to our presentation.
So most of them, I will say. We have a last question. I do not know if it's right yet or if you want to answer this afternoon in your TechSurf dialogues. The question is, do you know of SIP providers supporting ISC?
Yes, there are some providers that support ICE as well, but that depends obviously on the SIP provider. You can always check our wiki where we have the configuration and the test results of the provider, and there it says if the provider supports ICE or not. Okay, thank you.
I think we are done. We will have, I'm really bad with the agenda every time, with a coffee break, I guess, or, yeah. So now, in 3 minutes, so we are a little bit earlier, so we can still discuss, but I think we are talking enough.
There are no more questions, so
thank you everyone.
Have a nice coffee break.
Yeah, and
bye-bye.
See you this afternoon.